Okay, so we're into factoring polynomials, and example 1 tells us, it gives us a factor of a polynomial that follows, so let's factor the second polynomial completely. I want to remind you on how to do synthetic division. Now, the book will also show in this chapter, if you want to go back and look at it, the book will also show you exactly the steps to do long division with polynomials. I tend to not do that. I tend to adjust my synthetic division procedure for, well, any factor. All right, so a reminder on how to set this up. I'm going to build my synthetic division box. In the top row of my box goes all of the coefficients of the polynomial that I'm trying to divide. And I want to make sure that I have all the terms. If there's a missing term, you have to fill in a 0. That's one of the things you want to watch out for that'll make you nuts about synthetic division if you don't do that. Also, the other thing you want to be aware of is if you're given a factor, you need to change the sign. Now, if they give you a 0, then you don't have to change the sign. They've already pulled it out of the factor. Okay, so again, to start our synthetic division, we just pull the first coefficient down. Now we multiply -2 times 1. We combine the next column. We multiply by -2 again. We combine the next column and multiply by -2. Okay, so this is the remainder theorem that says if my remainder is 0, then x plus 2 is a factor of this polynomial. So let's write in polynomial form our original polynomial. So there's the factor we just divided out. And now I'm going to write the 1, 6, and 9. Those are the remainder as coefficients of the remaining polynomial. And here's what we've got. A reminder that our original polynomial is degree 3. So if we divide it by an x, our remainder is going to be 1 degree less. So remember to subtract a degree as you're rewriting your original polynomial as factors. Now that right-hand quadratic is a perfect square quadratic. It can be factored to x plus 3 times x plus 3. I'm going to write it as x plus 3 all squared. And it is completely factored. Okay, on to example 2. Use the rational zero theorem to find all possible rational zeros. Okay, it's not asking me to find all of the zeros for this particular polynomial. All it's asking me to do is list all possible rational zeros for the function. So what they do is they take a look at just the coefficient, the leading coefficient, the coefficient of your highest degree, and also the constant. All right, and we take those two numbers and we factor them. And we are going to, I believe they call the leading coefficient Q and our constant P. So we are going to look at the factors of P over Q. Now, P has a few factors, but Q only has one. And I'm going to put my plus minus in front. So I just have a 1. Okay, and I'm writing it here, but usually if Q is 1, we don't write it. So now I'm going to list the factors of -6. And again, plus minus, so I'm going to ignore the negative because I'll have both plus and minus. So I start with 1. 1's a factor. 2 is also a factor of 6. 3 is a factor of 6, and so is 6. So to list all possible, it would be, and all of these are divided by 1. So I'm going to drop the denominator. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So those all possible rational zeros for the function are going to be found in one of those 8 numbers. That'll help us to factor some higher degree polynomials in a bit. Example 3, is x minus 2 a factor of x to the third minus x squared minus 4? Well, if it's a factor, I'll do my synthetic division. I'll have a 0 remainder. If it's not a factor, I won't have a 0 remainder. And again, remember to change the sign because we're taking our number out of a factor. And on this one, I have 1 for my leading coefficient, and then x squared, it looks like it's a -1, but my x term is missing, so I'm going to fill in a 0. And lastly, I'm going to have the constant. Let's do the synthetic division, again, starting with just copying down the first number. 2 times 1 is 2. I get a 4. When I combine that, I get a 4. 2 times 4 is 8, and I do not get a 0. It looks like I get a +4. Because it's not 0, then no. X minus 2 is not a factor of that quadratic. All right, example 4 is actually asking us to do the very same thing, but instead of giving us a factor, they're giving us a 0. So let's set this up. And again, because they're giving us a 0, I don't have to change the sign. Let me fill in all my coefficients, x to the 3rd, x squared, x, and 15. No missing terms. The other way I know it is if I have a 3rd degree, I will always have 4 terms. 5th degree, I'll have 6 terms. So you just count the terms to see if you missed one. Okay, I get a 0. So yes, -1 is a 0 of that polynomial. All right, I'm going to end this video. I'll see you on the next one.